All right, now we do number 1A. It's saying, according to Coulomb's law, how will the magnitude of the force between two charges change? Magnitude of the force between two charges. What is the Coulomb's law? Coulomb's law says the force between two charges is proportional to the product of the charges and inversely proportional to the square of their separation. So it's inversely proportional to their separation. So here I am reducing. So what happens? So you can say the force should increase. Okay, so when, according to Coulomb's law, okay, according to Coulomb's law, when you reduce the separation, the separation between the two charges, then what happens to the force? The force between them increases. Okay, increases. Then we go to part B. A test charge, blah blah, is at a point where the electric field. I want to see the question first. What happens to the electric field and electric force? Okay, when you do what? What happens to the electric field E and force F? When you do what? Is a test charge, blah, 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 is directed to the right and there's a magnitude. If the test charge is replaced with a charge of -3 microcoulomb. So this is a +3, positive test charge is at a point where electric field, due to other charges, is directed to the right. And there's a magnitude of this. If the test charge is replaced with a charge of this. Okay, so what happens to the electric field? So point number 1, we just have an electric field which is going to the right. So electric field, we know that it comes from positive to negative, let's say that. So we have a test charge that is just in the field. So it's not the one making it. This field is caused by other guys, we know that. So we have put a test charge, a positive one. Then we've said we have removed that positive test charge and we've put a negative one. Why is it not changing, Craig? Oh, I'm writing on a different. So we have removed and we've put a negative. I'm choosing the clear on the wrong side. We've now put a negative. What happens to the field? Well, the field never changes. You have changed the charge, but the field is being made by other guys, not that charge. So basically, it was never made by this positive guy. He was just placed in the field. So what happens to the electric field? Electric field remains the same. So much the same. Then what happens to the electric force? Now this is what happens to the force. The force on the charge changes. What happens to the force on the test? The force on the test charge. Okay. The force on the negative test charge. Let's say that negative test charge is opposite in direction. Okay, to the force that was acting on the positive test charge, on the positive test charge. Okay, test charge. Okay. The magnitude of the force doesn't change. You should just say that for the third mark, I think. The magnitude of the force does not change, but the direction is what changes, does not change. Why? The magnitude does not change because we are putting the same size. It's a 3 and a 3 one again. So the magnitude, but the direction is what then is reversed